Okay, welcome back, everyone. So this is very, very short, and just please be patient with me. I know we talked a little bit about coral reefs and all that stuff, but I do want to mention a couple other things. So please just be patient with me. The objective of this module, again, is to sort of look at other life forms and other environments that have been impacted or will be greatly impacted by global warming and climate change, okay? So I do want to just mention a couple other things, and I don't want to be repetitive with this. But let me go to my handout here with this. So we know that when we look at things beyond sea level rise, warming oceans, acidification, and stuff like that, we know that oceans have the largest population, more population, if you will, than the land, okay? So we find more life in the oceans than not. And we know that coral reefs provide a very, very important habitat for a lot of that aquatic life. Not only food, but also protection, things of that nature, okay? So again, what we want to see, and again, I'm just asking you to kind of hang with me. This, of course, is the optimum. This is what you and I want to see when it comes to our oceans and our coral reefs. Now, you'll notice these very vibrant colors and stuff. This is obviously an indicator of great health amongst that coral reef. You'll also notice these very colorful fishies can sort of disguise themselves against predators, you know, within this habitat. So we know that oceans, okay, and healthy corals are very, very important with this. Now, I want to point out to you is that, you know, these are a rainbow of colors, and many of these coral reefs are relatively close to the surface. So you'll notice here in this image, this, of course, is a bleached reef. This is not what we want to see. This is the result of acidification and things like that, and also the warming of the oceans. But I want you to notice here is that you'll notice these scuba divers, they're not too far from the surface of the ocean. So that sunlight is able to make its way down, helps with the photosynthetic process. We do have coral reefs, of course, that are much deeper, but these are much slower growing, okay? And so what happens here, of course, is that when we look at this, we know that, of course, if they're higher to the surface, they're absorbing more heat, they're more exposed to the actual surrounding environments as well. So I want to point out to you that when we look at these coral reefs, they, of course, are a great signature of what is happening with our oceans, okay? All right, so when we look at this, we know that, of course, that this becomes a little bit of a challenge. So you know that this is coral bleaching. Now, I've mentioned to you guys before, it's important for you to know, is that the mean pH for the oceans is about 8.1. I've already said that to you in another discussion. And so we know it's slightly more alkaline or basic than it is acidic, but we are sort of moving into the opposite direction with this. The world's largest coral reef is found off the northeast coast of Australia. And you know this as the Great Barrier Reef. Okay, and so let me bring this up. Okay, and so when you notice this, you'll notice here it's in green. It's very close to the coast. Okay, so you're not going out into the middle of the ocean somewhere. And it extends about 1,600 miles. Being as close as it is, of course, it falls prey to a lot of the problems the runoff the land has, especially things like fertilizers and stuff like that. And I know that's got, you know, we're talking about global warming, climate change, but it does aid in the acidification of the oceans, all right? And this is very close to not only land, but it's not very deep as well. If you go to the Great Barrier Reef, and if you ever go to Australia, I mean, I can't recommend enough for you to go out of your way and go to the Great Barrier Reef. I mean, if you like swimming in the ocean, you can take these tours of the Great Barrier Reef that are just absolutely phenomenal. It is worth every cent, every effort to get there. And one thing, of course, is that you have to go with guides because they don't want you standing on the reefs. I mean, that's actually against the law. If you're caught standing on the reefs, there are heavy fines with this. But the thing of it is that they're very shallow. You can actually, you know, look, you know, if you're on a boat and you look down, you can see the vibrant colors. It's very, very close, okay? And so, of course, that makes them that much more susceptible to environmental impact. Okay, so let's go ahead. Let me go back to my outline here so you can kind of follow along with, oops, sorry, didn't mean to do that. All right, here we go. There we go. Okay, so you've got the Great Barrier Reef. And by the way, if you ever go south of Florida into like the Virgin Islands, US Virgin Islands, there's also a lot of coral reefs in that area as well. The coral reefs are probably the most diverse of all marine ecosystems, okay? Not only because of the calcium, but the food and the protection and everything that they provide for aquatic life, okay? And the problem is that once they become bleached, they are largely abandoned by life forms, aquatic life. It no longer feeds, it no longer protects. These are just largely abandoned communities, abandoned ecosystems, okay? Everybody takes off because it's no longer, providing the habitat that the aquatic life needs. But I do want to sort of make sure that you understand what is actually taking place with this. So when we look at this, all coral reefs have what are called polyps, okay? Now, when we as human beings, we think of polyps, we think of maybe sort of precancerous. But these polyps are very, very important. And what they actually do, so if you look at the bottom left image here, so here's part of a reef, you'll notice again how shallow it is, okay? All right, and then if you sort of zoom in, you see these polyps, if you will, here. And what happens is that as other organisms sort of swim by, these polyps sort of grab, okay? So they have these sort of arms of tentacles, if you will, and they sort of grab those organisms as they swim by, and they sort of feed that reef and that coral, if you will. All right, and so here is something that you see a little bit different color, all right, with this, but these are all polyps here, and they become very, very important with this. So as the oceans become more warm and they become more acidic, it greatly impacts these polyps, and so they are no longer able to grab these organisms to sort of provide habitat, if you will, for other aquatic life. Now, this is what is commonly referred to as zooxanthellae, okay? So I know that's a mouthful, so it's pronounced zooxanthellae. And this is, if we sort of give a close-up here, you'll notice sort of this yellowish brown color. And what happens here is that not only does it give a lot of the reefs their vibrant colors and nutrients, but what it also does, it provides a lot of food, and that results in a lot of photosynthesis, okay? Because it's close to the surface typically, all right? And that sunlight, that along with the zooxanthellae, sort of creates this photosynthetic process. And that provides habitat. And that's what sort of keeps the reef sort of healthy. The deeper the reef is, of course, you don't quite have, it's kind of small, or it's very limited, it's very slow growth. A reef can grow by about 6 to 7 inches a year. Now, you might not say that's much, but it actually is pretty significant over time. The depth plays a very, very significant role with this. Now, the deeper that reef, of course, it might be a little bit more protected, but it's a very slow grower. The higher that reef is, or the closer it is to the surface, it's a little bit faster growing, but it becomes a little bit more impacted by the environment, as I said. So there's a number of different things with this, all right, that sort of come into play. So a coral actually begins as a colony. And what will happen here is that colony grows into a reef, okay? And so this is sort of this building process that takes place. Now, I told you I was going to keep this very, very short, but I do want to mention something to you, and this is really what I'm going for here with this. Not only is the reef sort of a provider of habitat and protection for a lot of aquatic life, they're also what are called pteropods, okay? And so what is happening here is this. We know that in a previous discussion that, we believe that the oceans, the temperatures have risen between, say, 1 and 2 degrees Fahrenheit. On a grand scale, 71% of the Earth's surface covered in these oceans, and that heat distributed across, that's very, very significant. We also know that, of course, acidity levels are dropping in the oceans. We're at 8.1. And the forecast, of course, is that we're talking about maybe a pH of 7.8. That is very, very, very significant. We're now getting closer, of course, to neutral and making our way down to acidic. And I want to point out too, the National Oceanic Atmospheric Administration has done a lot of studies on this. And one of the things that they're looking at is that not only the reefs, but also these pteropods. Now, I need to point out to you, pteropods are very important foodstuffs for anything from blue whales to other smaller organisms, everything in between. They are a primary source of food. And you'll notice when you look at the pteropod, it's very skeletal. There doesn't appear to be a whole lot to it. And what NOAA has done is that what they've done is they've taken these pteropods and they said, okay, the pteropods are surviving in the oceans that we see today with this 8.1 pH, with a temperature drop of about 1 to 2 degrees Fahrenheit. They're surviving. And what they did is they took pteropods and they put it in a simulated environment, much like the oceans. But what they did is they increased the oceans by about another 1 to 2 degrees Fahrenheit, and they lowered the pH to 7.8. So they were creating an ocean, if you will, of what is believed to be the future, what is forecasted. So they put the pteropods in there and they found within about a 30 to 45 day in that type of water, the pteropods completely dissolved. They were non-existent, okay? Now, that was rather alarming to oceanographers, to biologists, to people, studying the oceans and things, and said, oh my gosh, that if these temperatures do continue to rise, if the pH continues to drop, we are potentially looking at the loss of a primary source of food for marine life. Now, I don't think NOAA, in my opinion, I've done a lot of stuff with them. I've used a lot of their data. I don't think they're extremists or alarmists and stuff like that. But they just said, look, we've recreated this environment over and over and over to test our methodologies. And we've had other groups look at it as well and say, all we did was just increased it by another degree or two, and we just lowered the pH to 7.8. And this is what we came up with. The pteropods completely dissolved within about a month and a half, okay? So I just wanted to mention this to you guys because we have been talking about oceans, and I know I've kind of beaten you over the head with coral reefs, and we're gonna move on from this. But I did want to mention to you this is just another impact, another ecosystem, something else that's going to be impacted with the warming and the changes that we're seeing, okay? All right, so we're moving into our second to last module, okay? So you're almost there, hang in, and let me know if you have any questions or concerns, okay? Have a great day. I'll check in with you soon again. Bye.